Yes, good afternoon to all. Okay, once again, welcome back to the today's session. Today we are going to cover only a small topic that is pending in our unit number 1. That is the rectifier with filter. Now we covered the concept of half wave rectifier and full wave rectifier. And only the small topic is there. That pending topic is with filter, what is the output we are going to obtain, that we are going to see today. Okay, it is a very small topic. It may not take more than 10 minutes. Okay, now we will see this topic now. What is a rectifier? In last classes, we discussed rectifier, which converts an AC signal, alternating current signal, to your pulsating DC, or you are calling as exciting DC signal. Now, what it contains? The output of rectifier will contains AC ripples as well as the DC component. It has the two components. Pure DC we are not getting as the output of the rectifier. Output of the rectifier will contains some AC ripples and as well as the DC component. Now, if AC ripples will present at the output of the, if you are connecting any device to the output of the rectifier, if any fluctuations are there due to the AC ripples, that device is going to damage. Now what we are going to do, we are going to remove the AC ripples, and we have to provide a constant DC, the DC continuously to the connected device. Now for that purpose, to remove the ripples or AC component present in the output of the rectifier, now we are using different types of filters. Among those filters, only capacitor filter we are having in the syllabus. That only we are covering in the today's class. Now we are having the capacitor filter, inductor filter, a combination of these two, LC filter, now pi section filter. These are all the different types of filters. But all these filters we are not covering. Only the rectifier with the capacitor filter only we are covering in the today's class. Okay, what is a simple thing? The main function of this filter is, what is the main function of a filter? Now I am not talking about the rectifier and all those things. Now see, this is nothing but your rectifier output. See, this is nothing but your rectifier output. Now previously you are connected, one diode is connected here, a transformer is connected. Now this line is nothing but your output of rectifier. Now there you are connecting one capacitor and it is followed by the load resistance RL. Okay, this is the simple capacitor filter connection. I will show you the half wave rectifier and full wave rectifier separately with the capacitor filter. Meanwhile, we will see what is a filter, what is a capacitor filter, and how it will remove the AC component, AC ripples present in the output of the rectifier. That we will see in the present slide. Now the main function of the filter is to allow the AC components and to block the DC components of the load. Now people are aware of that. And now this capacitor will block the DC component. It will allow only AC component. Why also you know very well. Now what is your XC reactance value? XC is equal to 1 by 2 pi FC. Here it is there. And now what is the frequency component in the DC signal? For a DC signal, the frequency component is 0. Now what is 1 by 0? 1 by 0 is the infinity. Infinity reactance is there. Reactance infinity means it is an open circuit. It will not allow the DC component. Now that's why now capacitor will allow only the AC component and it will block the DC component. Now whatever the output, this is the rectifier output we are getting at this part. This rectifier output will contains the AC ripple as well as the DC component. Now this AC ripples, this will be allowed by the capacitor. AC component is flowing through the capacitor and the capacitor will block the DC. The DC is directly obtained at the load resistance. Some people raise the hand. Now what is the problem? People are able to listen my voice? Okay. Yeah, if you're having any problems, simply type in the chat box. The two other faculty are there. The ma'ams will clear your doubts. Okay. Right. Now, this capacitor will blocks the DC. Now, from where this is a basic, this is a simple relationships. The reactance is given by capacitor reactance is 1 by 2 pi of C. Now, your frequency component is 0 for your DC signal. Now, that's why 1 by 0 is infinity, reactance is infinity. A reactance is nothing but the resistance is infinity is there. Nothing will pass through it. That means the DC signal will not pass through the capacitor. And now, AC signal, it is frequency component is not 0. Now, that's why it is some defined value, so that it is a low reactance path. That's why capacitor will allow the AC signal, it will block the DC signal. Okay, a typical capacitor filter circuit diagram is shown below. This is a simple capacitor filter. Now, the designing of the circuit can be done with a capacitor as well as the load resistance. When capacitor is connected in parallel, when load resistance is connected. Now, this is a simple circuit, capacitor filter circuit, connecting at the output of the rectifier. Now, rectifier's exciting voltage in the sense this is a pulsating voltage or output of the rectifier is given across the terminals of the capacitor. Now, between these two terminals, you are applying the output of the rectifier. Now, whenever a voltage of a rectifier enhances, then the capacitor will be charged. That means in this rectifier output, if any AC pulses are there, now that is flowing through the capacitor. Now, with respect to that AC source, that capacitor is going to be charged. Now, if any DC component is there, the DC component will block the DC component. From these two terminals, directly DC component will be comes and it is appeared across the load resistance band, and as well as supplied to the current to the load. That we will discuss this with respect to half wave rectifier and full wave rectifier. This is a simple capacitor filter circuit diagram. Now, what is a capacitor filter? It is a capacitor and a load resistance connected in parallel. Now, the input of this capacitor is nothing but the output of the rectifier. You are directly connecting to the capacitor. This is a simple capacitor filter circuit diagram. Now, what is a half wave rectifier with capacitor filter? Now, we will go in detail about the half wave rectifier and full wave rectifier. First, I will show you the diagram and then I'll come back to this three parts. Now, this is a half wave rectifier. I think people already know the half wave rectifier diagram. What is half wave rectifier? Now, this is up to this part is a half wave rectifier. One diode is there. It will conduct only positive half cycle. Now, previously we directly were taking the load resistance here, but if you are adding the capacitor parallel to the load resistance, this is with a capacitor filter. Now, this is a half wave rectifier circuit diagram with a capacitor filter. If there is no filter here, simply this diagram is half wave rectifier, HWR. Now, what is the diagram with the filter? With the filter means with capacitor filter. Now, the capacitor must be connected across the two terminals of output of the rectifier. I hope this diagram will be clear. Now, I move on to the operation of this half wave rectifier with the filter operation. Now, what will happen? The main function of half wave rectifier is to change the AC current to the DC current, the general. But that is not the direct DC current. Now, for that purpose only we are using the rectifier. However, the acquired output DC is not pure. Now, whatever the DC you are getting at the output of the rectifier, that is not the pure DC output. And it is an exciting DC or the pulsating DC. Now, this DC is not constant and varies with time, because some AC ripples are there. AC is the frequency component is there. Now, it will vary with respect to time. It is not a constant DC. That's why whenever this changing DC, that means this DC is impure DC, is given to any type of electronic device, then it may not function correctly or that may get damaged. For example, if you are constant 230 volts, if you want to provide, for example, a DC source, constant 12 volts you are going to provide to the simple mobile charger. Now, if any AC ripples are there, if it is fluctuating at the 15 volts or 9 volts, 14 volts, 10 volts, it is fluctuating, voltage is fluctuating, then the electronic gadgets, they are going to damage. They cannot tolerate these fluctuated values. They are designed for the constant DC voltages. That's why whenever varying DC is given to any type of electronic device, then it may not function correctly or that may get damaged. Now, what we have to do? We have to remove the AC ripples. That means what is the changing value that if we are able to remove that part, then the DC, constant DC, if you are connecting to the electronic device, then they are not going to damage. Now, that is why thus we require a DC that does not change with time. Now, even though time, with respect to time, even though time it is varying, my output voltage is not going to change. That is nothing but the constant voltage it must be. Now this is what we are expecting in the practical cases. Okay, to overcome this problem and to get a smooth DC, filters can be used. The main purpose is why we are going to use the filters means, now this is the reason. What is the main reason? Now to overcome the problem of, this is a problem. That means to get a smooth DC, the filters can be used. Okay, the energetic DC, other name of energetic DC is nothing but your pulsating DC. The output of rectifier mainly includes both AC and DC components. It contains both AC and DC components. So here the filter is used to remove or reduce the AC components at the output side. Now, if you are able to reduce or suppress the AC components, then the output of this filter is nothing but a constant DC. Continuously, it is supplying the same amount of voltage to the electronic device. Now, this is simple introduction related to your capacitor filter with a half wave rectifier. Now we will go for with the positive half cycle. What is going to happen? Now, generally, capacitor will store the charge. Whenever it is the charge present in the capacitor is less than the applied voltage, it can charge. Now, up to what extent it can charge? Up to the maximum input voltage extent, the capacitor will charge. If you disconnect the input voltage across the capacitor terminal, it will discharge through the load resistor. Now that we are going to see in the next slides. Now see, what is going to happen? Whenever AC voltage is applied to the circuit, throughout the positive cycle, what is going to happen? Now I applied the AC voltage across the transformer primary winding, the secondary winding also same signal I am getting. Okay, step down signal. Now that is given to the diode positive half cycle. But during the positive half cycle, the diode let the flow of the current through it. That means current is flowing to the diode. Now this is a half wave rectifier operation I am telling. We know that the capacitor gives high resistant lane to the DC component. High resistive lane in the sense it is nothing but your infinity resistive reactance value, capacitor value. For the DC, it will block the DC. That's why it offers a high resistance lane as well as it offers a low resistance lane for the AC component. Now, the flow of current always choose to supply through the low resistance lane. Nothing is there here. Now here the capacitance is there. Now here the resistance is there. Now for this is the signal you are applying to this is the signal. Now for the AC ripple, now for the DC component, now capacitor will block the DC component. That's why for the DC signal, now it will offer a high resistance path. Now compared to this, that's why DC component will not enter into this. Now DC component will appear across the load resistance. For AC signal, it will allows the AC signal. That's why it offers a low resistance compared to this. That's AC signals are flowing through the capacitance. Now that is the meaning of this statement. Now we know that the capacitor gives high resistance lane to the DC component as well as low resistive lane to the AC component. Now the flow of current is always chosen to supply through a low resistance path. Now that is what we are going to choose. Right, now see. So when the flow of current gets the filter, the AC component experiences a low resistance and the DC component experiences a high resistance from the capacitor. The DC component flow through the low resistance. Ultimately, this capacitor is blocking the DC component. It is offering high resistance path to the DC component. Now it is going to flow through the low resistance value. Now, throughout the conduction time, the capacitor gets charged to the highest value of the voltage supply. Now, during this time, what is going to happen? DC only, DC ripples, they are going to the low resistance. With respect to the AC component, now this AC, it will allow the capacitor. With respect to this AC component, the capacitor is going to get fully charged. Whenever something is flowing through the capacitor, automatically it is going to store some energy. That's why with respect to the AC ripples, capacitor is going to be fully charged. Now, that's why as the voltage among the two plates of the capacitor, how much voltage is there in the capacitor, that is equivalent to the voltage supply. Now, how much voltage you are supplying at the input side, now same voltage is going to be developed across your capacitor. Okay, now once the rectifier reaches to the negative cycle, now what is going to happen? If it is diode takes the negative cycle, it is going to be an off state. Now off state means nothing is flowing to the capacitor. Now this path is nothing but the open circuit path. Now it is not connected to any, this is an isolated path. What is going to happen? The stored charge in the capacitor, it is going to discharge through your load resistance value. Here also, this is a constant value. It is not affected with the input signal because input signal diode is in the reverse bias. There is no signal flowing through the diode. It is completely open circuited. Only the charge present in the capacitor is discharging to the load resistance valve. Okay, now throughout this, the supply voltage is low than the voltage of a capacitor. The capacitor releases and all the stored energy current through the RL. Now this stops the output load voltage from falling to nil. Now what is going to happen? Now initially during the positive half of the cycle, diode is in on state, so the maximum current is flowing to the load resistance, DC current is flowing to load resistance. Now whenever it is coming to the negative half cycle, instead of falling this to the zero immediately, now what is going to happen? The charge stored in the capacitor, it is going to discharge through this load resistance during the negative half cycle, so that the completely it is not becoming the nil. Now initially this is the DC voltage I am assuming. Now during the negative half cycle, it will reduce, not exactly the previous one, but it not come to zero value. Once again during the positive half cycle, it will attain the energy and it will fall. Now if you see the capacitor value, now it will charge, this charge is there. Now this is the discharge path. Now I can show you the diagrams here. I am not able to draw clearly. I will show you the diagrams. Now this is simple operation for your half wave rectifier. Now nothing is there. From this slide, what it is saying is during the positive half of the cycle, now what is going to happen? And now the diode will conduct. And now diode is conducting in the sense, now output of the diode, you are getting the both AC component and DC component. The capacitor offer the high resistance path for the DC component. Now that's why DC component is choosing the low resistance path. Now for the AC component, capacitance offers the low resistance path. That's why AC components, they are flowing through the capacitor. Now with respect to the AC components, capacitor is going to be charged. But during the negative half of the cycle, what is going to happen? Diode is in reverse bias. It is open circuited. There is no path from input signal to this path, filter path. Now whatever the amount of charge stored in the capacitor, that is going to discharge the load resistance. That's why during the negative half of the cycle, output across the load resistance, that is not zero. How much amount of charge is stored in the capacitor, that is going to discharge through the load resistance valve. So that's why now this stops the output load voltage from falling to nil. Instead of output voltage falling to the zero, because of the stored energy in the capacitor, it is some output is going to be flowing through the load resistance, even though in the negative half of the cycle. This is a simple operation of your half wave rectifier. Okay, nothing is there, only the two things you are going to remember. This is a capacitor filter, only capacitor is there. Capacitor will block the DC component, it will allow the AC component. Now that is the only point, that is the complete 4 to 5 slides. It is going to turn around only the simple point. Now whenever any DC component is there, capacitor will block, it is acting as open circuit. The DC component is flowing through the load resistance valve. Any AC ripple is there at the output of the rectifier, that is going to flow through the capacitance valve, because capacitance offers a low resistance path to the AC component. Now that is the only two things you are going to remember throughout the complete lecture. Now this is a half wave rectifier. Now we'll see the full wave rectifier with the capacitor filter. Nothing is there. Now this is a full wave rectifier diagram. Up to this part is full wave rectifier. Now without capacitor is nothing but this is a full wave rectifier. Now if before the parallel to the load resistance, if you include a capacitor here, now that is nothing but with the capacitor filter. Now what is the function of capacitor filter? Now it will block the DC component, it will allow the AC components only. Previously for half wave rectifier, only during the positive half cycle, the diode is conducting. Now that's why at the positive half cycle, during the positive half cycle, now it is producing a constant DC output. This is constant DC output. Remaining case it is going to be low, and so for positive it is high and low. In this case, now both the diodes will conduct during positive and negative half cycle. Now that's why it will never come to the zero state, not the zero. It will never come to zero, but every time the capacitor will charge for some amount of time, immediately discharges, immediately it is going to charge. Now that we will see in the next slide. Now once the input voltage is applied throughout the positive cycle, the diode D1 gets forward bias, already you know, it will permit the flow of current. The diode D2 gets reverse bias, it will block the flow of current. It is a simple full wave rectifier operation. During the positive half of the cycle, the diode D1 will conduct, diode D2 will not conduct. Okay, D1 allows the current, flow of current, permits the flow of current, the D2 will block the flow of current. The current in the D1 diode gets the filter. Now D1 diode current is get the filter and energizes the capacitor, but the capacitor charging will occur just when the voltage which is applied to superior to the capacitor voltage. For example, initially capacitor is already having some inbuilt voltage. Just imagine some 1 volt voltage already charge is there inside a capacitor. Now when it can store the charge, the applied voltage is superior than this, then only the capacitor can charge. Now that is the meaning of this. Now initially, if you directly include a capacitor in this, in the full wave rectifier circuit, we don't know the status of the capacitor. Previously, whether the capacitor was used in some other places, now our capacitor is freshly taken. If it is a new one, there is no charge stored present in the capacitor. If it is already used in some other circuit, and once again you are using the capacitor in this circuit, internally it may have some amount of storage energy. If the input voltage is more than this, then only the capacitor will takes the ripples value. That is the meaning of this. The capacitor charging will occur just when the voltage which is applied is superior to the capacitor voltage. Now when the voltage is switched on, then the capacitor will get charged immediately. If nothing is, there is no charge inside of the capacitor, whenever you are turning on the power supply, now with respect to this, immediately the capacitor is going to be charged with the help of this AC component of the rectifier output. Okay, the capacitor gets charged to the highest value of the input voltage supply. The capacitor includes the highest charge at the quarter cycle waveform in the positive half cycle. That I will show you the diagram graph, then you will get the clarity. Once the AC voltage begins to falling and turns into less than the voltage of the capacitor, after that the capacitor begins to discharge. Now if the input voltage is more than the, see when the capacitor will charge here, see the capacitor is there, input voltage is 1 volt is there. What is the up to maximum, what extent it can charge? Up to 1 volt it can charge. 2 volts is there, the maximum it can store up to 2 volts. 3 volts is there, 3 volts it can charge. 5 volts is there, it can charge up to 5 volts. Now for example, input voltage is falls below the 5 volts. Now capacitor is charged to 5 volts. But the input voltage is falls below the 5 volts. Now what is going to happen? The capacitor will discharges. Because input voltage is less, here higher voltage is there, automatically it is going to discharge. That is what it is saying. Now once the AC voltage begins falling, that means input voltage begins the falling, turns into less than the voltage of the capacitor. Now whatever the voltage of the capacitor, if it is less than the voltage of capacitor, then the capacitor begins discharging gradually. Now that is the case of your capacitor. Now capacitor will charges whenever the input voltage is greater than the capacitor voltage. The capacitor discharges whenever the applied voltage is less than the capacitor voltage, then only it can discharge in the reverse path. I will show you the graph here. Now see, this is a half wave rectifier. What is a half wave rectifier? This is a simple AC signal input I am taking. Now what is the half wave rectifier output? Now this is a half wave rectifier output. Half of the cycle only it is coming. And this is a half wave rectifier output. Now what is the capacitor? Now see what is going to happen. Now, during this time, the capacitor is going to be charged because it is more, input voltage is more, that's why it is charging. Now see, this blue color line is nothing but this is a capacitor. It is with the capacitor filter. See, in this capacitor DC line, there is no ripples, there is no zigzag, this type of ripples are not there. See the constant voltage it is there. But it is not constant means it is not constant like this. Now see the water. Now for the capacitor always we are going to use a refresh circuit. Well, because if the capacitor is having the 5 volts, during the discharging case, now if you want to maintain a constant supply, what you have to do every time you are going to refresh the capacitor circuits. Then only it can attain the 5 volts continuous. But here we are not going in detail about the refreshing circuits. Just what is happening now, this time it is going to be charged, and during the negative half of the cycle it is discharging, but it is not coming to zero because capacitor is charged up to maximum value, and then it is discharging up to this value, and during the positive half cycle once again the input voltage is more than this value, it is capacitor is going to be charged. Now whenever input voltage is falling, now slowly it is going to discharging the complete value like this. Now the capacitor only if I draw the only the capacitance output, now it is going to look like this. Now this is the output of half wave rectifier capacitance. Now what is the full wave rectifier? Now see, in the full wave rectifier you can observe here only the small thing you can observe. See the time is, see how much time it is in discharging state. Now it is half of the cycle it is in discharge state. But in this case, see that is not the half cycle. Now immediately first initially capacitor will charges up to this path. See output what I am showing, this is a capacitor output, it is not the filter output. See, this is a capacitor, how the charging and discharging will takes place. Now that only it is showing. Now, initially capacitor is charging up to this path. Now, later, whenever input voltage is false, this, now it is slowly 432, it is coming now. Now, immediately it is slowly it is discharging. During the negative half cycle, whenever it is greater than this, immediately it is going to charge once again. It is discharging, charging, discharging is going to take place. Now, if you compare this with half wave rectifier, now the discharging time is, see here, the charging time, it is charging time and the discharging time. Discharging time is less compared, we'll compare with the half wave rectifier. Because why it is very less? Because during the negative half cycle also another diode is conducting. Now due to that flow of current through the diode D2, that also containing the AC ripples and DC component. Now due to that AC ripples also, whenever that AC ripples are more than the stored capacity value, then it can charge the capacitor. Now like that, now first initially due to the diode D1, the capacitor is taking the charge. Now whenever it is negative cycle, due to the diode D2, capacitor is going to take the charge. Now this is, now see, this is a common point, and here you are applying the capacitor. This is a load resistance value. Initially diode D1 is conducting. Now so that output will contain the AC ripple content as well as the DC ripple content. Due to this AC ripple content, capacitor is charging. Now after some, whenever input is falls below this value, now what is going to happen? Up to some amount of time it is discharging, because input is 3 volts, for example, it is having here 5 volts is there. Up to 3 volts it is going to discharge. Whenever the negative cycle will comes, now this diode will comes into picture. Now this, the output of this diode is also containing the ripples, AC ripple as well as DC component. With respect to this AC ripples, once again it is going to charge. Okay, that means the discharging time is very less in full wave rectifier compared to the half wave rectifier. This is a small output for the capacitor, how it is going to charge, how it is going to discharge, charging and discharging time of the capacitor for half wave rectifier, and this is for your full wave rectifier. It is a very simple one, nothing is that there is no complication in this topic. Now with the filter, if you use the filter, what is the advantage of using filter? The filter will remove the AC ripples, it will provide a DC, pure DC component. Pure DC component means in that there is no ripples. Now 100% it cannot provide you the pure DC component, but it can suppress to the maximum extent. For example, 98 or 95% or 98%, all the AC ripples will be suppressed by the capacitor, because that is the AC is completely flowing through the capacitance, only DC is coming at the output side. Now that's the purest form of DC you can obtain at the output of the filter. Now that is a simple concept of your filter circuits with half wave rectifier as well as your full wave rectifier. Now once again see the diagrams. Now write this theory, this is not much required to keep in the slide. For only if in the examination, to write in examination only, I kept some of this theory here. Just read the theory, that is everything is already known to you. Only remember the 3 things. The first thing is now look, what is a capacitor circuit? Now first see this here. What is the capacitor circuit? It is a rectifier output. It is having capacitor in parallel with a load resistance. Remember this. Now when you are describing and you are writing something in the examination, include these 2 points. The capacitor gives infinite reactance for DC, because DC component frequency is 0. For DC signal frequency component is 0. With respect to 0, it is a 1 by 0 is infinity. Infinity means there is infinity resistance is there, nothing can pass through that. Now there is infinite reactance is there, nothing can flow through that. Now that's why now reactance is infinity. For the DC component, it offers the infinity reactance, that is like open circuit here. It will block the DC component. The other path for DC component is to directly flowing to the load resistance. Just remember the first circuit. And the second thing is you are having the half wave rectifier with the filter. Now in the regular classes are going to happen, you are having the practical sessions. Now there you are having the rectifier with and without filter are there, but it is very difficult to conduct the practical classes through this online mode. All the physical components are there. Now when the labs are going to happen, we cannot predict that. Now, if those labs are running parallelly with respect to these theory classes, it's still if you're having any doubts, that may be clarified with the help of your practicals. But only theory version we are teaching to you people. Now that's why a little bit. The practically, if you are seeing, if seeing means, then you will get the 100%. You will get the full picture about that. Now, what is the output of the all the ripples you can see? General output, rectifier output, what you are getting, you can see in the CRO. And now, what is the output of the filter? Also, you can clearly observe on the CRO part. Okay. Now, this is the circuit diagram of half-wave rectifier. Without filter means remove the capacitor. With filter means include the capacitor. Full wave rectifier without filter means remove the capacitor. With the filter means just simply include the capacitor. Now, what is the capacitor charging and discharging output? Now, this is an input signal. This is a half wave rectifier output, and this is your full wave rectifier output. Now, he will not ask you directly only this with filter circuit separately. He will ask you along with your half wave rectifier, full wave rectifier. He may ask you now explain the operation of half wave rectifier with the filter and without filter, and derive the expression for the some of the factors. Now, separately, there is no topic here, but if it is a 2 marks or 3 marks question, is that there may be possibility of asking what is the purpose of filter. Now, what is the simple like 2 marks questions, they can easily frame based on this topic. Right. Now, with this, now I am winding this simple topic, that is with the filter topic. And now with this perfectly, I concluded the unit number 1. Just I will read the syllabus copy here once. If any missing topics are there, so that we can cover. Right. Now we started with the junction diode characteristics. And now in that the open circuit PN junction, now we are seeing the band bending structures also. And now we are taking the Fermi level, what is the P type and N type, how is they are going to look like. Just I will show you the diagrams only with respect to topics, so that once again you can refresh here. Now this is the open circuit PN junction diode. It has a P region, N region, and this dotted line is nothing but your Fermi level. This is a band structure of your open circuit diode. And then we started the PN junction as a rectifier. Now see, at the time of while covering, I skipped this part as a rectifier. Now I covered this rectifier along with this rectifier part. Now what is a rectifier? How the PN junction acting as a rectifier? Now this topic now we may going to see in the second half. And now what are the VI characteristics? We already plotted the VI characteristics of PN junction diode. Now what are the voltage versus current characteristics? Now in the forward bias, after the cut-in voltage, the barrier potential, you may call as the 0.7 volts for your silicon diode, and germanium is the 0.3 volts. After that, beyond that only, the current flows in the forward bias. The reverse bias, there is no current flow theoretically, but practically there is a reverse saturation current is flowing through the PN junction diode. Now what is the effect of temperature? Now whenever temperature increases by 10 degrees temperature, now the reverse saturation current will doubles. Now reverse saturation current is increasing means ultimately the problems also increasing to us in the practical side. Now we are going to reduce the leakage current. That is our main important. Then we have seen the diode resistances, 2 types of resistance, static resistance and dynamic resistance, or the AC resistance or the DC resistance. Now then we start discussing about the diffusion capacitance and the transition capacitance. Diffusion capacitance is going to see in the forward bias, because diffusion of the main charge, majority charge carriers will diffuse from one region to another region. Now that's why the offered capacitance is diffused capacitance. The transition capacitance is nothing but it you can see in the reverse bias. Okay, the transition capacitance is very large compared to the diffusion capacitance. The diode switching times. Diode switching times also I discussed. Now perfect switch. Now what is going to happen? Now during the switching time of this diode, the minority charge carriers plays a major role. And now in the forward bias, minority charge carriers are very high, very large near the junction. In the reverse bias, they are very low at the junction. Now that I discussed in the last class, the switching times. And then the breakdown diodes. Now there are three types of breakdowns are there: avalanche breakdown, Zener breakdown, as well as your thermal breakdown. Now generally we may not consider thermal breakdown. There are mainly two breakdowns are there: avalanche breakdown as well as the Zener breakdown. Zener breakdown is mainly due to applied voltages. If you are applying a large electric voltage, due to that when a breakdown occurs, that is nothing but your Zener breakdown. Avalanche is due to the high reverse voltages. If you are applying the more and more reverse voltage, more than the 10 volts and the like reverse voltage of more than 10 volts, if you are applying, then due to that the lot of charge carriers, they are going to release, the breakdown will occur. That is avalanche breakdown. Now then we discussed about the tunnel diode. Now what is the tunnel diode? It is different with the p-n junction diode. The concentration, that means purity concentration, is very very high. Now in case of normal diode, one part of impurity you are adding for 10 power 8, but in tunnel diode you are adding one part of impurity for the 10 power 3 atoms. That means more and more impurity is there. Due to that, if the impurity concentration is more, now the barrier width is very very thin. Now because of very thin barrier, thin depletion region, now even though it is not more than the general forward bias is nothing but more than the cut-in voltage, barrier potential, diode is in forward bias, then the current conduction will take place. But in case of tunnel diode, even though applying the smaller voltages more than the 0 volts, now with that voltage also a large amount of forward current is going to take place. That is due to the tunneling of the charge carriers. Okay. Now there are two types of currents are there. Tunnel current is there, diffusion current is there. Now there is a peak, valley point is there, peak point is there. Now that already we have seen in this fashion. Now like we are having, now this is the graph is going to comes like this, it is going to forward bias. The reverse bias, it is acting as like a normal p-n junction diode. And then we discussed about the photodiode. What is a photodiode? But whenever light is falling on the p-n junction, p-n diode junction, according to that, and now there is an electric current is flowing through the p region to n region. Diffusion of charge carriers will take place. The photodiode will convert the light energy into electric energy. Now what is a light emitting diode? Which will convert the electrical energy into light energy. Now that means it will emit the light, but it will absorb the light. These are the two differences between the photodiode as well as your light emitting diode. And then we discussed about the diode applications. First we started the clipping circuits. Now there are two types of clippers are there: series clippers and shunt clippers. Now, meanwhile, series and shunt also there are into two types: positive clipping and negative clipping. If any positive peak is clipping at the output side, that we are calling as a positive clippers. If any negative peak is clipping, that we are calling as a negative clippers. And then we start the comparators. Now we are taking the ramp signal as the input, and with respect to the ramp signal, just we are comparing the input signal with the reference signal. If the output is a constant output you are getting, that indicates input is smaller than the reference signal. If you are getting the output is following the input, that indicates input signal is greater than the reference signal. That is only comparison is done by the comparator. Generally, these comparators, we are not going to use the diodes. We can use that 741. That means operational amplifier you are going to use as a comparator. But that will be for EC people. Diode comparators, practically we are not using anywhere. Now it has very limited importance we are having. Next, we started the rectifiers. In the rectifiers, we started half wave rectifier and the full wave rectifier. And then we discussed about we derived the different parameters. What is the DC current and the DC voltage? Now, average current, you are having RMS current and RMS voltage. What is the form factor, peak factor, efficiency, regulation, and next ripple factor, transformer utilization ratio, peak inverse voltage. All these things we derived for the half wave rectifier as well as the full wave rectifier. And then today we winded up with the rectifier with the capacitor filter. Now we are connecting a only capacitor as a filter at the output of these two rectifiers. How that is blocking the DC value, how it is blocking the AC ripples. Now how it is eliminating the AC ripples, that we discussed in the today's class. Okay, I think this is the end of your unit number 1. I think 16th Wednesday people are not having the ADE class. I think all sessions are cancelled. Now on 17th you are having the ADE class once again. Today you people are not having any quiz because this is only revision class I have taken. Just I reviewed only the complete unit number 1. That's it. Today you people are not having any quiz session. Okay, in the next class onwards, Rajita madam is going to take over the unit number 2. Now unit number 2 BJTs. And now from the introduction onwards, madam will give you the complete introduction, and then unit 2 will be handled by Rajita madam. Okay, I hope unit 1 will be very clear to everyone. Today there is no quiz session today. Now already I shared all the PPTs, only except the today's class. I shared all my video lectures and all my presentations to your CR's group. Now I hope CR's also already shared to their respective classes. Go through the presentations. Don't open the PPTs only at the time of examinations. Now daily go through these PPTs and what are the material we are sharing, so that it will be very easy to you people. That is what I want to tell at the end of this class. Okay, that's it for today. And now only 15 more minutes are there. Now you take a break. Already you are exhausted with the today's classes. Meanwhile, madam, if you want to talk anything, Rajita ma'am. Rajita ma'am.
Yes, sir. Yes, sir. Sir, able to listen? Sir, hello? Students, are you able to listen? Hello? You respond, madam.
I think next class onwards, madam will be ready. Okay, unit 2 will be the BJTs. Meanwhile, if you are having the free time, just refresh the small fundamentals of BJTs. Madam will continue from the 17th class. Okay, with this, today I'm winding the class. Wednesday, why cancel this? Because from day after tomorrow onwards, final year exams are scheduled. Okay, now that's why, because all the faculty, they are in the invigilation duties. Now that's why they cancel, I think. Their strict instructions are there due to COVID we are having. Now only for every 12 students, only one faculty member, he is going to assign as invigilator, and a lot of manpower is required. That's why I think for that reason only they cancel. All the classes are cancelled on Wednesday, I think. But they said ADE class is not there on Wednesday. So that is what we are announcing to you people. And Thursday, once again, we will meet with the unit number 2. Okay. That I don't know exactly. All classes are only ADE. Just I am telling you only ADE class is not there on Wednesday. Now you will get the information through your concerned faculty. ADE class is not there on Wednesday. That's why next class they schedule on 17th. Okay, thank you.